Welcome back, statistics students. We are still on chapter 5, and we are actually still on, I put an 8 there. We're in chapter 5, okay, and we are still on example 8. I did do an intro video to example 8 where I went through A through C. Now we're going to do E, D, E, and F, okay. It's still the cows, okay, we still have the same mean and the same standard deviation. And we're still just kind of answering the same type of questions. But now we're kind of working backwards. It says, what weights are in the lowest 20%? Okay, so here I draw my curve, right? And 1152 is here, down the middle. Now, lowest 20%, that means that I'm thinking about, like, what weight right here, right? I'm thinking about a weight that makes this area down here 20%, okay? Well, here, I'm working like backwards. I have the percentage, which is against what we did on, the first part of example 8. Now we're working backwards. Because we're working backwards, it should cue you to say, oh, I'm working backwards, inverse norm. I'm doing the inverse of the norm. Oh, okay. Now remember, in our calculators, we can come over here, and what we're looking for is we're going to second distributions, right? There's a bunch of inverses. Oh, inverse norm is this 3. We hit it. Okay. And now, my calculator here has the left, center, and right. If yours doesn't have that option, you're always going to have to put the left area in this spot. Okay. But because mine does have it, right, I get away with not having to do the left area. Most calculators, I think, have this now if you buy them new. If you have an older calculator, though, I will show you that you should just always put the left area in here. Okay, so the left area, oh, that's 20% here, so it's 0.20. Yes, you have to change it, which makes this area 0.2 up here. No need to change anything else. Paste it, get it, and it kicks out a z, this is a z-score now, of negative 0.842. It should not shock you that it's negative because it's below the mean, right? This is below the mean. Because it's below the mean, it should be negative. That doesn't shock us, okay? Now, that's not the question, though. It's not. The question is not find the z-score. It's find the weight. So here I unravel the z-score. Remember, z is equal to x minus mu over sigma. Well, z is negative 0.842. That's a 4. And that's equal to, well, I don't know the weight, so it's x minus mu is 1152 divided by 84. Now I just have to unravel that. Over here, my calculator will do it. So I already have the bit up here. Without any rounding, I can actually multiply that by 84. Then I have to add over my 1152. And I get a weight of 1,081.3 pounds. Okay, so this spot right here corresponds to 1,081.3 pounds. All right, that shouldn't be too bad. Again, if you're feeling confused or if you want to speed up, you need to pause the video and or skip to the next one. Okay, we're going to move on though. For part E then, now all of a sudden we want to find the weights are in the highest 5%. Oh, I almost forgot up here, because it's the lowest 20%, it could be this weight or lower, right? And then up here, we're doing something similar, except now this percentage out here is 5%. Right? This is a 5% value. It's still 1152 down the middle, but I don't know what this is. Here we're doing inverse norm. If you don't have a fancy calculator, you have to do the left area. The left area is 0.95, right? 100% for the whole thing, 5% at the top, 95 to the left then. If I do second, my distributions, 3 would give me the inverse norm. Now I'm doing 0.95. Staying with the left because that's what I'm using, right? Hit enter, I get 1.65, right? That's z equals 1.65 0.445. Now, it shouldn't shock you that it's positive. It's above the mean. If you're a person wondering, well, why didn't you just use the right? Most calculators now have this. You can do the right, which would be, okay, to the right, that's 0.05. You just have to then change this one. Now, it should give me the same answer. And you can see that it does. Okay. Now we're using the z-score. Okay, well, z is equal to x minus mu divided by sigma. Well, z is 1.645 equal to x. I don't know what it is. 1152 is the mean, and 84 is the standard deviation. Now we just use our calculators, right? We multiply that by 84. We add 1152. Remember, mentally we should be thinking this is a bigger than the 1152, which it is. It's 1290.2, and that's pounds, or higher, right? They could also weigh more than that. Okay. And there we have our answer to part E. Okay. On to the last one here for example number 8. It says, what weights are in the middle? 80%? All right. Let's think about this. Let me get a different color here. So it says the middle 80%. Now it does say middle, so when we draw this, that means this part in here, down the middle, is still 1152. But I want its middle, so like this entire section in here, I want to be 80%. Okay? There's a couple different ways you could do this. Okay, a few different ways you could do this. I think the easiest way to think about this is if this is 80% in this part that I'm shading, right here. I don't know where this is or this, but these should match. Okay, one will be negative and one will be positive, because there's 40%. There's 40% in each side, okay, which makes up the 80. Now, if this is 80% in here, that means that there's 20 between this edge and this edge, okay, which means when I go to do the inverse norm, and if I stick to the general rule that I'm supposed to do the left area, from this spot here that I'm trying to line here, down, how much data is there? Well, there's 80 right in here, plus there'd be 10 more sitting in here. Because there's 10 there, that's 90. The other 10 sits out here. So when I'm doing the inverse norm here, I'm doing inverse norm of 0.90. Okay? Now, that will give me this z-score. So if I do second distributions, right, we get the inverse norm. I do see the right is up there. We'll change that here in a minute. I get 0.9. Down, we want to highlight the left. Paste it. We anticipate this being positive, and it is. I get a z-score equal to 1.28. Or 2, okay? Which isn't all that surprising. It's positive. Now, technically, this one over here should be the same. Because I want to show you a couple different ways to do it, I think I will go through. Here, if I went for this one, that's what to the left? Well, there's only 10%. So second bars, hit my 3. If I went 0.1, 10% there on the left, I'm anticipating that to be negative 1.282. So let's see if that's a correct assumption. And you can see it is, right? There's a couple ways you could do it. Obviously, we know that these one's negative, one's positive. You could also use the middle term like I have on my calculator. No biggie. Or you could use the right one. Next, though, what I really have to do is, I get that these are z-scores, but now I have to set those equal to, or unstandardize them which means if I'm going to unstandardize them, I am going to have to take negative 1.282 equal to x minus 1152 divided by 84. That'll give me the lower bound for weights, and then I do 1.282. I don't know why I put another 8 there. 2, right? And that's equal to x minus 1152 divided by 84. And now we're just going through and we're doing each one of these weights. Now, what I hate seeing is some students do this one over here and then think, oh, I'll just make this one negative. We're not saying a cow weighs negative pounds, okay? So that'd be a very incorrect assumption. Instead, we have to take this value times by 84. I'll do the negative one first. Then I'm adding 1152. And that gives me 1,044.3 pounds to, now that's the lower, right? So I get that to the upper, which is 1.282 times 84 plus 1152, which would give me 1,259.7 pounds. So a cow that weighs in between those two weights would be in the middle 80%. Okay, and there we have it. That finishes example number 8. Okay, we have one last example inside of chapter number 5, and that's coming up in the next video.